Hello, my name is LuisChacin, and today I'll be presenting a project or an experience that challenged me and its relevance to my intended career in quantitative finance. I would definitely say that it was the C++ certificate for financial engineers offered by QuantNet. It's a 16-week C++ certificate that culminates with a project where the student is required to price European options as well as perpetual options using a three-way methodology, using Black-Scholes exact formulas for call and put, using Monte Carlo simulation, and using FDM as well, finance difference method, in this case explicit Euler, to solve the Black-Scholes PDE, to make the grid and get the prices at different space intervals and time intervals. Now, for the student to even attempt the first option of solving through Black-Scholes, we have to create a class hierarchy that will help us not only create American and European option objects, but also to be able to provide them with certain attributes and methods that we desire. So the C++ certificate takes you along and presents you the concept of the class, of inheritance, of polymorphism. It also takes it a step further. Many undergraduate courses don't offer generic programming, and this certificate does. And what this allows you is, you get the data encapsulation concept of object-oriented programming. You get data hiding, and it also allows, that idea of generic programming allows our classes to definitely be more reusable. So you're able to define a European option that maybe its prices are only stored in integers, or maybe it's only stored in doubles or floating point. So it allows more reusability, it allows more flexibility for our classes. For the student to even attempt the other two methodologies, Monte Carlo and FDM, the student would need a data structure to store a lot of the data that is simulated, or at least until maturity. And we would also need the ability to have random number generators and probability distributions to be able to simulate data. So the certificate introduces you to, one, the standard template library, where we have many different data structures like vectors, maps, AVL trees, also known as sets. And you can choose one of these data structures based on the speed in which they store data, based on the speed in which they retrieve data as well. So it's up to you to decide based on your needs. And the boost libraries allow you to choose many different random number generators, from Merson Twister, from John von Neumann's middle square, multiply with carry as well. And it also allows you to have access to probability distributions, which you pair up with a random number generator to simulate a lot of the data. Now, why is this relevant to my intended career in quantitative finance? I want to be a quant trader, and I'm well aware that high-frequency trading relies a lot on C++, because of its low level. It's low level as a programming language that allows you to have a lot of control over memory. It also gives a lot of execution speed that you don't find in other programming languages like Python, for example, that usually use interpreters, and that carries on a lot of overhead. And two, I plan to become part of the NYU trading team that goes on and compete at these trading competitions in U Chicago, at Rodman, at MIT. And having C++ under my sleeve will give me an edge over other trading candidates that might not know C++ that well. It also will put me in a position to be in contact with many of these prominent trading institutions that usually host these events, and be able to obtain some of these some of the prices and internships that they offer. Thank you for watching this video. I hope to hear from you soon. Thanks.